Reference angles are green. Full angles start from 0. Given the ratio of the angle in standard position with terminal arm in the stated quadrant, give the exact values of the remaining trig ratios. Cos equals x over r. So what do I have there? It's in quadrant 2, yes? So, where's the x? Can r ever be negative? So x has to be negative, so that's negative 2. What's this? 3. What's this automatically? Because I know how to do Pythagoras, because I've been doing it since the 7th grade. It is the square root of 3 squared minus negative 2 squared, which is the square root of 5 minus 4. 9 minus 4, which is the square root of 5. Now I know the y value. Is it positive or negative? Positive. So sine is y over r, root 5 over 3. Tan is y over x, root 5 over negative 2. Done. Done. These will be worth 2 each, because you had to understand the quadrants as well. Where is quadrant 4? Down there. Sine is negative 1 over 3. Where's the 3 go? Blue line, vertical line, or diagonal line? The 3. Diagonal line. Can it ever be negative? Which means this must be negative 1. Which means this is the square root of 9 plus, not 9 plus 1, because I had the hypotenuse, 9 minus 1, which is the square root of 8. So, that is now my x value. So, cos is x over r, root 8 over 3. Some of you will tell me 2 root 2 over 3. Does that make me happy? Of course it does, because 2 root 2 over 3 is the actual best answer. But at this point in the year, I take what I can get. Tan is y over x, negative 1 over root 8. Also for 2 marks. That page so far is out of 8. Quadrant 3, that is down here. This is tricky. It's 3 over 5. How can the tan be 3 over 5 when I'm in this part of the world? Because that's negative 5, and that's negative 3. So what's this? That is the square root of 3 squared plus 5 squared this time, because I need the hypotenuse, which means the square root of 9 plus 25, which means the square root of 34. So my tan I have, my sine is negative 3 over root 34, and my cos is negative 5 over root 34. And finally, 8, negative 5. Would it? Y, sine is y over r. This is the square root of 8 squared minus 5 squared, which is the square root of 64 minus 25, which is the square root of 39. I've got my cos, so my sine equals negative root 39 over 8, and my tan equals root 39 over 5. Positive, because both of those values are negative. Making that out of 4. The sine is 5 over 13, positive 5 over 13, which is y over r. 5, 13, 5, 13. 1 mark. 2 possible values of cos. Cos would be down here, yes? The x value. which would be 169, 13 squared, minus 25, 5 squared, which is 144. The square root of 144 is 12 and negative 12. So the two values of cos are plus or minus 12/13, also for 1 mark. Find the values of theta. You will use shift any one of these numbers to find the value. You will find either this, green theta, or if you use cos, some of your calculators will give you proper theta. Thank you. Some of your calculators will give you proper theta if you do shift cos negative 12/13. It will give you proper theta. But you already had sine, so I would, of course, use sine. Second sine 5/13. And that gets me 23 degrees. So theta is 23 degrees for green theta, and then black theta, which goes all the way around, would be 180 minus 23, which would be 157. 2 marks there. If cos equals negative 1/3, find the possible values of theta. That means cos has to live down here. No, I lie. Has to live there. There's the 3, there's the 3, there's the negative 1. I only want values of theta, so all I got to do is shift cos once with my calculator. Shift cos negative 1 divided by 3 to get 109.47. So this is 109, which means this is 71. Which means what's this? 71, which means what's this? 180 plus 71, which is 251. 2 marks there, making that page out of 2, 4, 6, and 4 is 10, and 8 is 18. I will collect those marks from you at a future time when I am less frustrated. So possibly next September. Can everyone do trig up to here? Page 162. Now, you will notice, what is page 162 entitled? Special triangles. Have we seen that terminology before? No, not in this class. But if you did your homework, you saw it on page 158. Special triangle. Which means you could go back and do this now. Right? Now, that last question that your Kira had asked about with the design and that is doable, as you could see, with algebra. After this lesson, you'll be like, oh, okay. All right. 45, 45, 90. Talk to me about this triangle. Where's the 90? Where's the 90 degrees? Opposite to the hypotenuse. But since none of that's labeled, where's the only place the 90 can be in here? Just use directions, ladies and gentlemen. Bottom left. There's my 90. Agreed? All right. Since I am telling you that the other two are 45, that creates an isosceles triangle. I will never ask you to spell that or actually know its definition. No, I lie. You do need to know its definition. I don't care if you can spell it. An isosceles triangle is a triangle with two equal angles And if they have two equal angles, they have two equal sides. Now, a special isosceles triangle is this particular one. Because not only is its dad, I'll just say dad. Not only is its dad Greek, because it's an isosceles triangle, its uncle is Greek because it's a right angle triangle. So who's this triangle's uncle? His Greek uncle. Starts with a P, ends with an S, has Pythagora in the middle. This is a very special isosceles triangle because it's also a Pythagorean triangle. Yes? Now, since it is Pythagorean, the two blue sides are the legs, aren't they? Right? And we know they have to be the same, yes? Now, if we were doing math, do we know this distance? No. So what would we do with it? We'd give it a variable. What would be a good variable to give it? X. We always choose X. You guys are so boring. There's 26 other letters. But fine. We'll use X. So that's X and that's X, correct? What do we know about this triangle? That x squared plus x squared will equal the hypotenuse squared, will it not? How many x squareds do you see there? 2x squareds will equal h squared, yes? Which means x squared will equal h squared over 2, yep? Which means x will equal the square root, plus or minus, of h squared over 2, correct? Everyone agree? All right, so we can all understand the algebra, yes? Now, what would be the easiest number to give to the letter x right now? It can't be 0 because you can see it's got a distance. What's the next easiest number to work with? 1. So it would be 1 squared plus 1 squared would equal h squared, yes? So 1 squared plus 1 squared would equal h squared, yes? If I square root that side, I would get h, would I not? Right? Okay, so what's 1 squared and 1 squared? 2 equals h squared, yes? So what does h equal? How do I get rid of that squared to get to h? Root 2. So x, we made them 1 and 1, which meant that was root 2. Do we agree? Okay. If it happens once in math, how often does it happen? All right. So if this was 7, 1 is now 7 times bigger, isn't it? Right? Which means what would this one be? 7, which would mean what would this one be? 7 root 2. What if this was 312? What would the hypotenuse be? 312 times root 2. What if it was 876.7? What would the hypotenuse be? See how many people can remember that number I just said. 876.7. Or was it 867.6? I can't even remember now. Who cares? The point is, whatever these are, this is always root 2 times that. Always. In a 45, 45, 90. Everybody understand? That's the easy one to work with. We're all cool with it? 45, 45, 90. That means that it's 1 to 1 to root 2. Which means, you're intelligent young people, the sine of 45 is 1 over root 2. The cos of 45 is what? He waited patiently. But you don't need to memorize it, Joshin, because you know this. No, Joshin, you do. There's 45, right? Sine is opposite over hypotenuse. 1 over root 2. opposite over hypotenuse. Well, this side is the exact same, isn't it? So what's the cosine of 45? Cosine is adjacent over hypotenuse. So what is it? 1 over root 2. And what is the tan of 45? 1. Because it's 1 over 1. Right? Always. No matter how big the triangle gets. Right? That's why trig works. That's why it's glorious. Now let's look at the slightly more difficult one to work with. Where is the 90? Bottom left. Yeah. Now the other two angles are obviously, as I've said in here, 30 and 60. Yes? Where must 30 be? Top or bottom right? Bottom right. This must be 30, correct? And what must this be then? 60. Excellent. What do we know about triangles? Which side is the longest? Hypotenuse. H. Which leg is the shortest? Left or bottom? Left. Because it is across from the smallest angle, yes? It must be the shortest because the two endpoints are the closest together, because 30 is a much smaller spread than 60, yes? So this side must be the shortest side, yes? If this is the shortest side, does it make sense to give this the variable? It does, doesn't it? Right? Because everything should be in terms of that smallest variable, yes? Like on this side, x and x, they were the same. So if we're going to make this x, and we shouldn't use x this time, why? Seriously, like x, we shouldn't use xy, no laughter. I know I'm in a bad mood, but that doesn't mean comedy doesn't mean comedy. There's comics that yell at you and you still laugh at them. Did you? Laugh with some gusto then. Why shouldn't I use x and y here? Because what have we just been using x and y for? We've been using it on the coordinate grid, yes? And y is the uppy-downy one, yeah? So if I make this x, that's confusing, yes? So what letter could I use instead? I would use A and B because you're used to working A, B, C, right? A and B. Does everyone agree? Everyone's cool with that? Now, what would be the easiest number to give to A? 1. Does everyone agree? Okay. So now, let's look at our math. Here I have a theta of 30, yes? Everyone agree? Sine theta would equal 1 over h, correct? Everyone understands this? What then does h equal? H equals 1 over sine 30. Does everyone agree? Everyone's cool with that? Okay, watch what happens. 1 divided by sine 30. 2. So what is h? 2. So h is 2. Are we now able to find the third side? How? Our good friend Pythagoras. B equals the square root of h squared minus a squared, correct? What is h squared? 4 minus what is a squared? 1. Root 3. So how big is b? B equals root 3. How often? Always. If you have a 30, 60, 90 triangle with 1 and a hypotenuse of 2, what is this side automatically? Root 3. What if this was, again, 7? What would this be? It would be 14. And what would this be? 7 root 3. What if this was 22? What would this be? 44. And what would this be? 44 root 3. Does everybody understand? Now watch. 30, 60, 90. 1, right? 60 was root 3 and 90 was 2. What? These values are what is opposite the angle. 30 is the smallest angle, so it's across from the smallest side. 60 is the middle angle, it's across from the middle side. Because the square root of 3 is 1.73, yes? 1.73 is less than 2. 90 is the biggest angle, so it's across from 2. Everybody cool? Now, what does that tell us? Well, that tells us that the sine of 30 is always 1 over 2. The cos of 30 is always root 3 over 2. And the tan of 30 is always what? 1 over root 3. Which also tells us that the sine of 60 is always what? The cos of 60 is always what? One over 2, and the tan of 60 is always what? Root 3, because it's root 3 over 1. Everybody cool? Always. Now, let's do some work with that. Turn the page over. Find exact values, draw the terminal arm, find the reference angle, identify the special triangle, label the sides, and use the trig function. All that, believe it or not, all of that you already know how to do. Remember, no calculator. Sine 45. Where's 45? Right there. Agreed? If that's 45, make your triangle. There's 90, there's 45. What do we automatically know? If it's 45, 45, 90, what do I automatically know the hypotenuse is? Root 2. And what's this? 1 and 1. We're done. And we know all the rest of them from SOHCAHTOA, yes? Okay, let's do B, because B is harder. B will do gold. Where's 60? First quadrant. It's the big angle, yes? Right? So if this is 60, this is 30. What's across from 30? 1, the smallest one. What's across from 60? The middle one, root 3. What's the hypotenuse? 2. And then I can do sine, cos, tan, can't I? Let's do this one in light blue. Where's 330? Down here, yes? This is the 30, isn't it? Which means this is what? 60. What's across from 30? 1. What's across from 60? Root 2. What's across from 90? I lie. Sorry. Root 3. What's across from 90? 2. Now, this one is a tricky one. Why? Because it's x, its y is negative, and its x is positive. And I'm out of colors on this palette. This guy, 225, is right there, yes? Which means 45, 45, 90, 1, 1, root 2. What's tricky about D? There's 2 negatives. Ease bees lemon squeezy, right? Now, please notice how we are bringing Pythagoras, algebra, and acts all to this party, yes? Please notice each day there has been one new layer added to your previous trig knowledge. When you think about it, it all started with SOHCAHTOA, right? Everything we've done is based on SOHCAHTOA. Except in grade 9, or in grade 10, your SOHCAHTOA was always in the first quadrant, wasn't it? So, 240, is that going to be a 30-60-90 or a 45-45-90? That's going to be a 30-60-90. What about 210? $30-60-90. Why? We'll talk about that in a sec. What about 150? 30-60-90. What about 315? Pardon? No. That's a 45. Why? Well, where's 240? Where's 240? Third quadrant. What is that distance? 180. How far did I really have to go? 240. So what's this in here? There's our 60. Which makes this what? 30. Which makes this automatically what? What kind of 1? What kind of 1? -1, which makes the hypotenuse automatically what? +2, because the hypotenuse is always positive. What does that make this leg? -√3, and then you could do SOHCAHTOA. This one. Where's 210? Down here, yes? What's that? 180. So what's this? 30. So what's this? So what's this? Across from 60 now. -√3. What's this? -1. What's this? 2, because the hypotenuse is always positive. 150. Where's 150? There. What's that? 180, but I only needed to go 150. So what's that? 30. So automatically, if that's 30, what's that? 1. What's that? 2. What's that? -√3. And lastly, 315 is down here. What's that? 360. I didn't need to go 360. So what's that? 45. So automatically, what's that? 45. So automatically, what are these two? One and what kind of 1? -1. And what's this? √2. Why is that one positive when I'm dropping down? Because the hypotenuse is always positive. Why is the hypotenuse always positive? Because as soon as you square a negative, what do you get? A positive. Everybody good? Now, your carrot. Do you see how knowing this would have made that last question on that other page easier? Why would I try to get you to do that last question before I taught you this? Because couldn't we figure this out? We figured it out using exponent or algebra, didn't we? So when you work it out the hard way, then I give you the shortcut. Why? Because I want you good at math, not good at memorizing shortcuts. The rest of your math career has been taught you to memorize shortcuts. How's that working out for you? Right. How's actually being able to do math working out for you? Slightly better. All right. Root 3 and 2. What do you automatically know? What kind of triangle is this? That's a 30, 60, 90. How do you know it's 30, 60, 90? Because it's got root 3 and 2, yes? Right? Okay. What else do we know about cos? Cos is, say it loud and proud, Jashin. Adjacent over hypotenuse. What else do we know about cos? X over hypotenuse. So, since this is A over H, but it's also X over R, where is the only places that H can be positive? This is a trick question. I did it on purpose. Where are the only quadrants where H is positive? Every single one of them. Stop it, Mr. Myers. So, where is the only quadrants where that root 3 could be negative? In quadrant 2 and quadrant 3, because the root 3 is adjacent and it's X. So there is my negative root 3. The hypotenuse must be 2. Correct? So what is this automatically? I've got root 3 and 2. What's this? 1. What's this? Negative 1. What's across from the shortest leg? 30, 60, or 90? 30. So what is this right here? 30. What is this in here? 30. Thank you, Jack. So what is this if this is 30? 150. What is this if this is 30? 210. Gouda? Great. Automatically, a 1 and a root 2. 45, 45, 90 or 30, 60, 90? $45, 45, 90, yes? Sign is positive. Where must it be? Second quadrant or first quadrant. If that's the root 2, then that's 1, 1, 1, 1. This must be 45. This must be 45. So what is that? Dude, thank you. 45. What is that? 135. Yay! And lastly, root 3. 30, 60, 90, 45, 45, 90. 30, 60, 90. Why is this one weird? What's its denominator? Automatically. 1. Tan is negative. Where must it be? Quadrant 2 or 3? 4. Root 3 is the y or the x? Tan is what? Y over x. So root 3 is the y. So here, the y would be positive. The x must be the negative. Down here, the root 3 is the negative. So the x must be positive. And what is the hypotenuse in both cases? 2, even though it doesn't really matter, does it? What's across from 1? Is this 30, 60, or 90? 30. So what's this? 60. So what's this? 60. So what's this? $120. So what's this? 300. Now, right about here is when half the class says, Liam, how did you know that so fast? And then about a quarter of the class, which is the half that says, Liam, how did you know that so fast? Stops for 1 second and says, oh yeah, 360 minus 60. But that last quarter of the class is still, Liam, you're a wizard. And then by the end of this joke, everybody's got it now. Yes? All right. Special triangles work no matter what the size. Okay? Class is over in 5 minutes. Now, listen to me. Go back and have a look at the 157s to 58 or 60 or whatever it was. I don't even remember. Those textbook pages. Because now that you know the special triangle stuff, your life might be easier. What is the next thing? Assignment 2. What will we be doing tomorrow by the end of class? Marking assignment 2. What else will we be doing tomorrow? Before we do that, what did you do Friday that we haven't dealt with? Your cumulative. We will be going over your cumulative and you will be getting it back. Aight?